Good morning, folks. So today, it's essentially a continuation of the stuff that we saw last time. So a little bit more about types and strings and expressions. We do have sort of a smaller example to work out at the end of the lecture today. So I'll sort of split folks off into the breakout rooms, and you can sort of work on that. And it's not too long, but the examples that we do today will be relevant for PA1, which should be up and available right now. I did switch the organization that it's using, so I didn't have any problem doing the sort of normal repository creation stuff that a lot of folks had problems with for PA0. So it should work just fine. The organization that it's under is actually Went Comp 3800, so you will probably see something related to that. Don't worry, it's all controlled by me, so I know exactly what's going on with your work. So don't worry about the sort of organization piece of it. As long as you have PA1 and the associated code with that, you will be good to go. The assignment that you have, we'll talk about it more tomorrow during a lab. During that time, we're going to work on the first part, so the first of the two parts of PA1A, and then the rest of the time during the lab, you can work on the second part, PA1B, or in principle you could take off as well. But essentially, we'll be doing the first part together. That way, I can give you some ideas about how to go about solving the problems for the homeworks, and things like what I expect in terms of commenting in an actual assignment rather than just sort of a contrived thing on the slides. So that's what you can look forward to tomorrow. And today's lecture is directly relevant to that. The examples that we have and the stuff I'm going to be talking about are essentially stuff you're going to use to complete that assignment. So we left off last time with assignment statements. That was sort of the last couple of slides. So I've sort of condensed that down into the most relevant slide for us to talk about. So when you do a calculation, and you will be doing calculations for the upcoming homework, when you do calculations, think of it as a one-time sort of math calculation that you're just storing the result of. That's the idea. That's the best way to think about it. So something like this, something like the calculation that I have here. We had total inches equals yards times 36. So presumably yards was created somewhere before this line. So maybe it was entered in by the user, maybe we just set it to some value, and then we multiply by 36 because there's 36 inches per yards. So this calculation will turn a number of yards that we have into inches. So it's our one-time calculation that at the end we have the total inches, and then of course we can print it out or we can use it to do some other kind of calculation. So when the statement is executed, when this line in, say, your code is run, Java takes the current value of yards and plugs it in, multiplies by 36, so all the right-hand side of the equal sign stuff happens first, and then it updates the value in total inches. This is an assignment. This is an assignment statement using the equals, which is an assignment operator. So it's kind of like your regular operators. It's kind of like a plus, a minus, a times, a divide, that sort of stuff. It's kind of like those, but it actually saves the value into whatever's on the left-hand side of the equal sign. So don't think of it like a sort of algebra-like equation that is sort of constantly updated or sort of constantly always true. Think of it as the one-time calculation. So that's the idea with assignment statements. And of course, we'll be looking at examples where, of course, we're using them. And really, you're going to see equals all over the place in code that you write. So I want to look at a common mistake. We got a whole bunch of stuff going on here. We got some variables we create. We have some user input. We have some stuff that's being printed out. All of this code, for the most part, shouldn't be too sort of cryptic just by sort of looking at it and going through sort of line by line. So something like the scanner, right? We talked about scanner last time. How do you create a scanner? For now, we're just sort of taking it for granted that this is the declaration for a scanner, how we read stuff in from the console. I declare a couple of variables, so input value and squared value. And then I have an assignment. I have a quick calculation. So I'm saying the squared value is equal to the input value times the input value. That should make sense. I multiply the input value by itself. That's effectively squaring it. Now the user input is underneath that. It's sort of further along in the code in that. So system out printf, enter the value, input value equals input.nextInt. So we talked about the nextInt and sort of next double ways to read in from the console. So that's what this is doing here. And then we print out. In this case, it's printing out something maybe a little bit more complicated than just a regular string, but it's going to do a %d and then a $2. So the $2 is printed verbatim. So it's not doing anything special. It's just text that's being printed. And then we have an equals, and we have another %d and a %n. So remember, %n is new line. %d takes the value from the list after your string. After what you're printing, it takes the value. So input value is first, so that's going to go here. Squared value is second, so that's going to go into this %d. Now, there's something wrong with this code. We never initialized input value. We say input value when we don't say it equals some number. So when I try to do the calculation, that's going to be a problem because it doesn't have a value yet. In principle, Eclipse or Java should give you either a warning or an error, depends on how things are set up. Other languages might just treat input value as being 0, in which case you would get a squared value of 0, which may or may not make sense if you don't notice the error. So the proper way to do this, the proper way to fix this, to have this work, the way that you intend is to flip the input and the calculation line. So the input here is where we get our value from the console. So the user types in a number, that gets stored in input value, and then we do the calculation. So the reason why I want to show you this is that if we go back to the previous one, is that this is not constantly updated. So even if I change input value, it doesn't recompute squared value. Remember, when we execute our code, we go one line at a time, executing in that strict order. So by having it this way, it's not going to print the correct value. We have to make sure that we do things in the correct order. And that's one of the big things when it comes to programming. The order that you do things is very, very important. So that's the idea with this little example. And of course, I'll flip over to Eclipse when we do some of our other ones to do some live coding for us. One of the toughest concepts when it comes to doing math in a programming language, and I still even forget, I'm coding up something real fast, I forget to pay attention to this concept, and then I end up with issues that crop up because I didn't sort of code in a careful way when doing my math calculations. It's this idea of integer division. When you divide two integers, the result is always an integer. Any fractional component is thrown out. So on the right-hand side of this equals, it's a 7, which Java would read as an integer, divided by 2, which is also an integer. So the answer to this, the value that gets saved after the assignment into the answer variable, is going to be 3. If we did this in a math class and you type this into your calculator, it would be 3.5. But because Java sees them both as integers, it will chop off that fractional value. It'll just essentially leave it out. The remainder can actually be computed as well. You use the modulus operator or the mod operator, which is %. So if I say 7% 2, this value will be a 1. Because we can evenly divide 3 times, so 2, 4, 6. So that's our sort of integer answer when we do the division, with the remainder to get to 7 being 1. Using this combination of division and some modulus operators is one of the ways that you can solve PA1B. You'll have to think about how to do it, think about how you can use the values. But this is one of the ways you can deal with PA1B. So we'll talk a little bit about it during the lab, but we'll do PA1A, but the PA1B is a little bit more difficult because you can use division and modulus. Modulus is a very common operation for sort of more complicated sort of step type things. So we'll talk more about modulus a little bit later on when it becomes a little bit more useful for the calculations that we want to do in our more complex codes. But it is an important operation, and it's one that's sort of worth at least knowing some of the use cases for. If you put an actual number, like we just did in the previous slide, if you put an actual number in a calculation, Java will treat it one of two ways. It will either be an int, or Java will treat it as a double. Even though you don't actually declare the value, you just put a number into the right-hand side of an equal sign, there's only these two possibilities. So if you don't put a decimal point after the number, Java automatically treats it as an int. So that's why in the previous slide, if I go back one, that's why these are automatically treated as ints, because there's no decimal point. So Java says it's an int. So anything you use with no decimal points, it's automatically an int. As soon as you put a decimal point and potentially other numbers after it, then Java automatically treats it as a double. Doesn't matter what the value is. So you could put 5.0. Technically, it doesn't have a fractional component because it's just zeros after the decimal point. But if I have the 0.0, it treats it like a double. This is very important because this gives you a little bit of control when you need to, say, divide by 2, for instance. So up here, if you want to divide by 2, if you want integer division, the 2 needs to be an int. If you want sort of a regular sort of math class division, then you'd probably want 2.0, for instance. So we're going to go over a few examples of sort of what you can do and what result you would get based on a calculation that you would do. So integer division, again, is one of those topics that folks tend to forget about and folks tend to have a little bit of trouble with. I forget stuff all the time. There's been situations where I spent hours trying to figure out what's wrong, and then I realized that, oh, I have an integer division where I did 1 divided by 2. Well, 1 divided by 2 in integer division is 0. So my result was always 0. And you spend hours trying to figure it out, and you realize, oh, it was just a dumb mistake. So that still happens to me as well. So it's something that you'll probably miss every once in a while after you get used to it, even after years of programming. So when we look at this calculation, it's an interesting one, and it's worth looking at the entire thing. So I have a value called result, and it's a double, which means it can contain a fractional component. But on the right-hand side, they're both integers. So then the question becomes, what's this result? If I print it out, the result variable, if I had a system out printf after this and I printed result, what would the number actually be? Treat the two sides of the equals separately. So just look at the 5 divided by 4 first. 2 integers, a division, 4 goes into 5 one time with a remainder of 1. So this value is actually 1. There's a 1 on the right-hand side, and it's an integer. It's an integer 1. When I save it by applying the equals, when I save it into result, then it turns it into a double. So we go from integer to double. Well, a 1 integer as a double is just 1.0. So that's the process. That's how I want you to go about thinking about these calculations. 5 divided by 4, integers, it's 1. It gets saved into a double. That's when it's converted to give me the 0.0. So even though the left-hand side is a double, that doesn't have any influence on the actual calculation in the right-hand side. So treat them separately. So that's basically what the text here says. Doesn't matter what type of variable sort of stores the result, just what the two values being divided are. Those are what's going to determine our calculation. The other important piece of this, and the sort of examples that are coming up are going to deal with this. If both the numerator and the denominator in a division are integers, then the value will be an int. But if even one of them is a double, then the value will be a double. So in this case, since 4 and 5 are ints, the result is an int, which is then converted to a double at the equal sign. So here's a few examples. A few more extra ones. Now, of course, if you're looking at the lecture slides, all of the sort of answers are already up here, but it's worth thinking about, worth making sure you know why you're getting specific results. So here's a very simple start. Int x. 5 divided by 2. 2 goes into 5 twice with 1 left over. So in this particular case, we have a 2, and we're storing it into an int. So the result is, of course, 2. Same situation, 5 divided by 2 on the right-hand side, but now we're storing into a double. So say this was on an exam or something. The result for this one would need to include the 0.0. So it's 2.0 now if you were to print it out. The next one is a little bit tricky. 5.0 divided by 2. So I just mentioned that if at least one of the two values in the division, if at least one is a double, then the whole thing becomes a double. So if I take 5.0 divided by 2, it's no longer an integer division. I actually get 2.5. So the right-hand side is a double. But then I'm trying to save it into an int. That's a problem. This will give you an error. And I'm going to flip over to Eclipse here in just a moment to show you what that error looks like. This will give you an error. So x equals 2.5. But you get an error by trying to save a double into an int. So let me show you in here. So I just have just a standard sort of blank empty project. If I say int x equals 5.0 divided by 2, it gives me the red squiggly underneath the calculation side. It sort of assumes that I did this correctly. I said int x, that's my intent, but that I did something wrong in the calculation. So it says type mismatch cannot convert from double to int. You can't do it automatically. So typing this in will give you an error in the way it's written. But if I change x, the value it's being stored into, to a double, then we're good to go. And the only sort of warning here is saying that I'm not using x for anything, which is true. So this will give me the correct value for what I want, whereas trying to save it into an int does not work properly. That's the idea with this one, and the next one is just the 2.5. So these are a couple things that are worth thinking about. What value are you saving it into? Does it make sense? And is there a double as part of the calculation? Okay, the next one is meant to be a little bit tricky. So let's go ahead and type that one in. And I'm going to, in Eclipse, I'm going to do the actual printing of it as well. So in here, let's say int x equals 5 divided by 4 times 4. And let's actually print that out. So I'll say system out printf. And we'll come into formats, and I'll just print out the value. And I'll do a %d because I'm printing out an int. And I'll do a new line as well. And then here, I'm just printing x. So when we run this, I get a value of 4. Now, just from looking at the equation, from looking maybe at the slides or at the code in here, it might not make sense as to why this is 4. This comes down to order of operations, and I do have a slide sort of mentioning what these order of operations are, but think of it like this. It's the same as math class, the same order of operations that you see in math class. So really, we start on the first number, and we say 5 divided by 4. Let's do that first. So this would be 1. 5 divided by 4 is just 1 with integers times 4. So that's how we get to this value of 4. So always start with the first value and move your way through, unless you throw in parentheses, which we'll get to that in just a second with the examples. So in this particular one, it's a value of 4. For the next one, that's when I throw in some parentheses. So the stuff in parentheses, you do that first. So if I go back to Eclipse and I throw in the parentheses around my 4 times 4, now we're going to get a different value, 0. So what's happening here? Well, we still have the 5 divided by, but we did the stuff in parentheses first to get 16. Well, 16, when we do the actual division, 16 is still an int. 16 doesn't go into 5 at all. It goes into 5 0 times. So we get 0 at the end. So just like in math class or when you're plugging stuff into your calculator, parentheses matter. And where you put them, whether you leave them out or whether you put them in, it's going to potentially change the result. So that's something that you want to be aware of when you're doing more complex calculations, where you have stuff that you need to be done first. Think like quadratic equation type things, solving for the roots of a polynomial or something. Think of that style of calculation where you potentially have parentheses that you need to put in. So that's why we get 0 in this next one. The next one here, it's saving into a double, so that's something for us to consider. But it's almost the same calculation as the one that's 2 above. That ended up being 4. In this one, there's no parentheses, so we just go left to right in our calculation. So I would still do 5 divided by 4. That's going to give me a 1 because they're both ints. Then I multiply by 4.0. So my answer is 4.0, because that's what I have left over. I have 4.0, saving it into a double, great. So it's basically the same as the one for the int, because I'm still doing the integer division here. I just have to look at the 5 and the 4. Both ints, I got to do the integer division. The 4.0 doesn't come in until later. And this is what the last one here. Let's take a look. Take a look at the last one. I want to show you what the result is beforehand, because I want to make sure that you can sort of see what these values are actually going to be. It will give an error because we're trying to save a double into an int. You see that we have a 0.0 on one of the numbers over on the right-hand side. So we know that at the end, this right-hand side is going to be a double. So we can't save it into an int. Okay, so we are going to get an error. But what's the actual value? We do 5.0 divided by 4. That is not an integer division. This is an actual decimal value. And then we take that and we multiply by 8. So 5/4 is 1 1/4, so 1.25. Times 8 is what gives us the 10. The times 8, 8's an integer, but the 5.0 divided by 4 is a double. So we do end up with a double here at the end. So the idea of putting in these 0.0, sort of 5.0, 4.0, the idea of putting those in are ways that you can control whether or not you end up with a double and what calculations are going to have, say, some sort of extra fractional component. It takes a little bit of getting used to when you're sort of coding and sort of working with this stuff to realize that, oh, I need to put a 0.0 here, or an integer division will work great in this situation. So it's not something that I sort of intuitively expect you to understand and fully grasp when to use these sort of 0.0s or integer division in certain situations. But these examples are sort of something to potentially come back to. If you're thinking, all right, how do I get this to be a, say, 2.5? Okay, I can throw in a 0.0, for example, on the first one. So are there any questions on any of these so far? Do you want me to go back over to Eclipse and show a couple more? do you guys have any sort of questions related to this? Again, you can unmute, you can throw it in the chat, whatever. So this is something that I do sort of expect that you'll probably mess up here and there. I still do. So I would expect potentially to have some issues with it. So if you get some weird value, something like especially 0, if you see it looks like you're doing a calculation right, but you're getting 0 instead, check for something like this. Check for an integer division that maybe you didn't intend. I have a quick note about multiplication as well. In sort of normal math notation, when you're just sort of maybe writing a homework by hand or something for a math class, you omit the actual multiplication sign. So you might say something like y equals 5x, and that would be it. Sometimes you might put like a dot or something for the multiplication, but for the most part, when I was doing my math homework, I wouldn't include sort of the multiplication sign. It's sort of intuitive, like, yeah, this we understand that it's 5 times x when I just write 5x. But in Java and basically any programming language, or most programming languages, you do have to include those multiplication signs. There isn't an implicit understanding that you're meaning to multiply. So something like this, my y equals 5x, would need to be written as y equals 5 star x. Otherwise, you will get an error. And the most common thing that I see folks do, I'll flip over to Eclipse, is potentially something like this. Maybe you're trying to save to a double, and I don't know, this is just the results. Delete the print here as well. I might see something like this, for example, where sort of implying that, oh yeah, it's 5 times the quantity, x plus y. You do have to have the multiplication sign there. Anytime that there might be an implied multiplication in a math class, you have to put the star to say what that calculation, to say that multiplication has to happen. So keep that in mind. All right, for more complex expressions, you can combine them into a single expression. You don't necessarily have to. You can create sort of more variables and do each little part and then combine them at the end. But for the most part, for longer sort of calculations, you can typically have them on one line. When in doubt, use a parentheses to specify the order of execution. So as an example, here is the value that would go underneath a square root if you're trying to find the roots of a polynomial, for instance, the roots of a quadratic. Something like this. Say b times b minus 4 times a times c. So this would be b squared minus 4ac. Again, you probably recognize that equation. If you're unsure as to whether, do I need the parentheses here? Is this going to work without it? When in doubt, throw it in. For the next equation, this is something you have to have. You have to have the parentheses here if you want this to work correctly. If I just did x times y plus z with no parentheses, that is absolutely not the same as x times quantity y plus z. So make sure you throw the parentheses in where they're appropriate, where the result would be totally different if you didn't have them, and if you're maybe in a little bit of doubt, like I'm not sure exactly how this is going to work, throw them in. Later on, you can take them out and sort of test and see if it's going to work with or without the parentheses. But when in doubt, throw them in. Be a little bit more explicit about what your intent is. The evaluation precedence is exactly what you've seen in math class. So I mentioned this a little bit before. Parentheses, of course, are first. Anything in the parentheses then follows the normal precedence as well. Multiplication and division are typically what you see in math classes. Also with that is the modulus in programming. So the modulus is part of multiplication and division. Then you have plus minus, and then finally the assignment sort of happens very last. If at some point you do end up using bitwise operators, or if you've used them before, it's not something we sort of typically do in CS1 and CS2, but if at some point you use bitwise operators, they have particular precedence in here as well. And typically you want to put them in parentheses because it can really mess with the order of operations if you end up using them. So you don't have to worry about it at the moment, but for regular math equations, it's sort of the normal sort of intuitive evaluation precedence with modulus added in. Okay, so we're going to do a couple of examples together as I sort of show you a few more things, and then again the sort of last exercise for the actual session today. We'll break you off into breakout rooms. So we're going to write a quick Java program that sort of does what you're going to be doing in the homework, at least in sort of a simplified sense. So we're going to read 3 integers from the user. So we did that sort of reading in from the user last time. So we're going to take that and we're going to combine it with doing a quick calculation. Calculate the average of the 3 numbers and then print it out. So it's a very simple program, just computes the average based on what the user put in. If you've looked at PA1 already, sort of similar in concept. PA1, you're going to enter a few numbers and then do a calculation, print out the result. So in concept, this is going to be pretty close to what you want for the actual homework. So let's hop into Eclipse, and I'm going to get rid of my little test thing here, and I'm just going to write the code directly in here. So we know we need to read something in from the user. So the first thing we want to make sure we have is the scanner. Typically, again, that's the first thing that I write in my program if I know that I'm going to need it. So I'm going to say scanner input equals new scanner system.in. Again, this is our standard, sort of take it for granted for now that this is what you want. We'll learn more about exactly what it's doing later in the semester. If you need to, you might have to put in the import Java util scanner. If you don't have that in there, you'll get an error on the scanner, and then you'll have to make sure that you put it in. The next thing that I want to write here is related to the variables that I'm going to be reading in. I'm going to throw a couple of comments in here as well. So I'm going to say, let's see, I want to read 3 values from the user. So I'm going to create those 3 values. I'm going to show you a slightly different way to do this rather than putting them all on different lines. I can say A, comma B, comma C. That'll create 3 integers for me. Okay. Next thing that I want is my average. I need to create a variable for the average itself, what I'm actually computing. So I'm computing the average. The average can have a fractional component, right? Even though I type in 3 ints, the average might be 2.5. So I should make this a double, and I'll call it average. So there's my variables that I need. Typically, I'll try to sort of put them at near the top of my program. In principle, you can create a variable anywhere you want in your program, but it is sort of nice most of the time to have them sort of together in sort of one location, especially if they're related in some way. So oftentimes when I do examples, you'll see me putting the variables first. And it can help to sort of organize your program. Be like, okay, I need to read in 3 values. I have them here. Let's write that part next, which is what we're going to do. And then after that, I compute the average. So it's worth thinking about the variables you need before you start writing the rest of the code as well. It can help sort of keep organized and sort of keep you on task. I'm going to do a print first. So I'm going to say enter 3 values, just like that. I'm not printing out any variables themselves, so I can get rid of the args piece here for printf. So I'm telling the user what to do. If I don't have this print here, then the user who runs my program is not going to have any idea what's going on. Like, am I supposed to type something in? Can I press enter? What's going on? So let's do that. And let's read in the first value. So I'm going to say A, that's my first value here, my first integer I created, equals input, that's my scanner, dot next int. And you can see all of the sort of next things here in the autocomplete. It might be a little small on your screen, but the first one that it comes up with is int. So it sort of knows. It knows that A is an int, so this is probably what I want. This is what's going to wait until I type something in, until I type a number. And then that number will be stored in A. But this is only one value. I need 3 values total. So I can actually put them one after another. And I'll show you what happens when you run, sort of how this functions when you run. So it's going to take my number from the console, save it into A. Take my number from the console, save it into B, my next number. Same thing for C. So that's my three values. I have them. In principle, they have numbers associated with them. So I could say something like A, B, and C should have values now. So now I can compute my average. So I'd say average equals, well, the average is just the sum of the values divided by the number of values that I did the sum of. So in this case, three values. So I would say A plus B plus C divided by the number of values that I actually used, which is in this case 3. Now, if I just do this, it'll compile. There's no errors. I don't have any errors that are sort of popping up here. But this is one of those situations where I should probably use some parentheses. Because right now it would do C divided by 3. It would save that number, and then it would do A plus B plus whatever that number was, C divided by 3. That's not what I want. I want A plus B plus C, and then all of that divided by 3. So throwing in some parentheses will give me the value that I want. Now, there's still something wrong with this, but we'll look at that in just a second after we run the program. So it's worth thinking about those parentheses, think about where you need to put them. So let's do a print, and let's print out the average. So average, this average here is a double. Average is a double. So I need to use %f for float. The args is going to be average. All right, so let's run. So it says enter 3 values. So let's say I enter 2. I press my enter key, so I just did, and it's just sitting there because it's waiting for me to enter the second value. So I can do that. Maybe I want to say 1. Now it's waiting for me to enter the third value, maybe 6. I press enter. It says the average is 3. And I don't know if I just picked random values from my keyboard, so I don't know if this is actually going to be the correct value. Let's see. So we got 7, 8, 9 divided by 3. So that should not be the average. The average should not be 3 in this case. Is that right? Yeah, the average should be 3 in this case. So let me try it. Let me try it again. Let me just do 1, 2, and 1. So it gives me the average of 1. That's not right. And it's because A, B, and C are integers. So we have an integer on the numerator of the division, and we have an integer on the denominator of the division. So this is an integer division, which means it's throwing off any decimal points. So if I want to ensure that this will give me a double, I can do something like this. I can say 3.0. So now I have an integer in the numerator, a double in the denominator, and that should now give me the correct value. 1, 2, 1 gives me 1 1/3. That's the correct value. So that's the process that I would go through for something simple like this. And say, all right, create my 3 variables I want to read in, create a variable for the average. Do the actual reading in, 1 variable at a time, compute the average, print it out. Make sure that I have the parentheses in the right place and that I'm not doing an integer division. I'm going to run it one more time, and I'm going to show you one more way to enter these values. Next int and next double and then the other next methods for the scanner, they just look for white space. So if I say 1, 2, 1, and I put spaces between them or tabs, whatever sort of white space you want, and I press enter, it will read them all in. And it'll read them all in correctly. So you don't have to press enter between each one. You can just put spaces. Any kind of white space will work. All right, and then of course the sort of solutions here, there's no sort of comments here. This is just one potential solution that you can use, but I do have, I think I have a couple of pop-ups here, things like, why do I need the 0.3 after the 3 here, the 0.0 after the 3? It's so we don't get that integer division. So if you come back and you look at these and you're sort of trying to figure out what's going on, there are sort of a couple things you will have to pay attention to. All right, so what if you wanted to input or wanted to output exactly 2 decimal places? So as an example, here we had 1 1/3, and we got 6 decimal places after this. But what if we only wanted 2 decimal places? We only wanted to say 1.33 and sort of implied that the 3's sort of continue. The nice thing about printf is that it gives you some other formatting capabilities, not just with sort of rounding a certain number of decimal places, but also stuff like separators, say for the thousands place. So instead of seeing 1, 2, 3, 4, you see 1, 2, 3, 4, for instance. Just different ways to format things, potentially for a non-technical audience. If you were writing a program that dealt with money or something, some sort of money type thing, maybe you'd want to put commas in the thousands place, for instance. So printf gives us some precise control. And typically you deal with this like large numbers, decimals, stuff like that. The thing that we've been using to put our string in, that's the format argument. That's the format string. So every time we put some quotes in our printf, that's the format string. That's why it can contain stuff like %f. That's why we put it in there. So this can contain the stuff that we've been using, those conversion characters, but it can also have extra flags to control stuff like this. So here's an example. I'm just gonna put a couple of these into our code that we just wrote, but this is sort of an example of showing sort of a bunch of them. So the code that we just wrote, let's say I wanted 2 decimal places. What I do is this: I put 0.2 between the % and the f. So any flags you want, any extra formatting you want in my float, I put between the % and, in this case, the f. So I do that, save it. I do my 1, 2, 1, and now I just have 1.33. So very easy to do, not a whole lot of stuff that you have to change. There's other stuff as well. You can, of course, combine flags, but things like the plus sign here should work for us. So we can do something like this, 1, 2, 1, and now you see that it includes the sign. So we have a plus here. So it's a positive number, for instance. So there's a whole bunch of these extra flags that you can use to do these types of sort of formatting or useful formatting on your values. The most common one for this class and for CS2 is controlling the number of decimal places. On some of your upcoming homeworks, I will say, output it with 2 decimal places. In which case, that's what you're going to have to do. You're going to have to make sure that you do formatting statements like this with the extra flag. Okay, so this sort of printing stuff here is something that you can take a look at. It's basically just using a few of these different flags to show you how they work, including for integers to throw in something like the comma for 1,000 separator. So you can definitely take a look at this as well. Of course, there's online resources where you can look at the different flags. Again, the most common ones are stuff like this: %, the comma, the sort of 3 decimal place stuff, or 0.3 stuff, and then some of the converters that we've used so far: D, F. If you want scientific notation, you can actually use E. And then things like new lines. So this is just a couple of them, some of the common ones, but there are a bunch more if you want to go look those up. So if we have, I just want to do just another very quick example, something sort of just a few lines, just to show that a little bit more. If you want to write it out, I'm basically saying, give me a decimal value. So in this case, the user will have entered 3.14159, and then output the value with exactly 3 decimal places. And we're going to look not only at what comes out, but also the rounding that happens. We have 3 decimal places. It's working, but it also is doing sort of proper rounding. So that's something that does happen. So we'll mess around with that a little bit as well, or at least sort of type in a few values where we could see that rounding. So this is basically what the output of the program is going to look like. So back over in Eclipse, I'm just going to delete what I have here, so I don't need it. I'll keep the scanner because we're going to be reading something in. So I'm going to create a variable to start with that is just my my value. So that's the value that we're going to read in. I'm going to do a print. And I'm going to say, so I have the format in the arg, so I'm going to say enter a value. I'm not printing out any values or anything, any variables, so I can just get rid of the args. And then I say input, say value equals input dot next. In this case, it's a double. Well, we need to make sure we change that because I need a double. So rather than an int, I need to use a double here. Yep. Because I'm going to be typing in a number with the decimal place sort of values after it. So I want to use next double. So that is something to keep in mind. If you type in something sort of incorrectly, maybe you're reading it an int, but you allow somebody to read it in as a double, then potentially you could get an error in the code. So we do want to read in a double. And then I'm just going to print it out. Again, but so I'm going to round it. So rounded. I'm going to do a percent, say 0.3f. So it's going to give me 3 decimal places. And we'll throw in a new line as well. The value I'm printing is just value. So if we run this and I type in that value of pi, then we're going to get the 3.142. Rounding is appropriate. But if I run again and I just type in 3.141, and maybe I put in like a 2, then we're just going to have it be rounded down to the 1. So any value I type in here, it's going to properly round it when I use the flag to give me 3 decimal places. So that's the sort of thing that I'm looking for. And again, to type in a number with F that has decimal stuff after it, I need to use next double, and I need to save that into a double. So relatively simple code, just dealing with some doubles and some rounding at the moment. So in some of your upcoming homeworks, I'll probably ask you to potentially do some rounding with a certain number of decimal places and potentially read in doubles as well, something that is not an int. And then the sort of example solution or potential solution is here. All right, so one more thing, and then we'll do the sort of final example where I'll break everyone out into the breakout rooms. So Java has a math library. So right now, the only stuff we've seen is sort of simple calculations: addition, multiplication, division, subtraction, that sort of stuff. For more complex things, say you want to do a square root, say you want to do a power or a log or a trig function, sine or cosine or something, you don't have to code those yourself. Basically, any language you use will have some kind of library that already has those functions built in, ways to do those kinds of calculations without you having to reinvent the wheel. So those simple things are essentially ready for you to use. You could write your own. It's probably going to be slower than the built-in ones, but in principle, you could write your own, like specifically something like absolute value. That's relatively easy to write your sort of own version of. If it's negative, multiply by -1. Otherwise, just leave it. That's an absolute value function. But they all exist already, and it's probably a good idea to use them. So for simple calculations, things that you would typically, there are extra buttons on your calculator or something to do them, Java has them already built in. Basically, every language does. So the way that you do it is by utilizing the math library in this way. So here's syntax. Let's say we want to do square root. So syntax is math. You always type math, dot, and then whatever it is you want to do. So for square root, it's squirt, S-Q-R-T. So you say math.squirt, and you put a value in. So for example, this, we do math.squirt, put in 100. The value that we get out at the end that's saved into S is going to be 10. Square root of 100 is 10. For something like power, so something to the something else, like in this case, 5 squared is what this is going to be. You do math.pow, and you say the value, so whatever is, in this case, like say a 5, and then what that's raised to the power. So 5 squared. So that's what this would be here, math.pow, 5, 2, gives me 25, which is saved into, in this case, P. So there's a whole bunch of these. If there's one that you haven't seen before, I will most likely sort of mention it in the homework, but you can look up a bunch of these functions. Like cosine is just math.cos and math.sin for sine. And for absolute value, it's math.abs, ABS. So there's a whole bunch of these functions. I recommend if there's some sort of calculation that you're doing that seems like it should be in the math library, it probably is. So things like exponential, right? Use like e to the, whatever, e to the x or something. That's there. That's math.exp. So they are there. If you've used various programming languages before and they've had a math library that you've used, you can basically use it in the exact same way. Typically, math libraries are very sort of commonly configured to work in very similar ways. So the only sort of caveat in Java is it's math dot and then the name of whatever you want to do. So math.squirt, math.pow. Later on, most likely much later in the semester or in CS2, you'll learn what this means. It's sort of math dot, why it's math dot, and then something. So there's a very specific reason for that. But for now, sort of use it as is. So here's a quick example. You will be doing something like this in the next exercise. So I just wanted to point out a couple of things here. Creating the variables, reading in a value, and in this case, doing both a power and a square root. So you read in a number, input value to the power 2, compute the square root, print it out. So you can take a closer look at this example if you want to when we're working on the exercise, because you'll be doing something very similar. So here it is. This is sort of the final exercise for today. There's a couple of slides after this as sort of a wrap-up thing. So most likely what we'll do is I'll give, a few minutes, 5-ish, 10-ish minutes or something like that, as both Dan and I sort of jump around to the rooms real quick. And then we'll all sort of come back together, and there's 2 slides after it with sort of a wrap-up. So the exercise here is writing a program that reads in 2 values. So stuff that we've just been doing, X and Y from the user. They can be ints if you want to. They can be doubles, whatever you feel like. You're going to calculate X to the Y. So X to the Y power. And then you're going to print out the result. And you can print it out in a similar way to the example in this previous one here. So print out with just a couple of decimal places. Have some verbatim stuff. Like in this case, it's float with 2 decimals, caret to 1/2. So it's like square root. Equals, and then a float with 2 decimal places. So you could do something like that. Print it out in some sort of useful way. That's essentially what I want from this. 2 decimal places. And then essentially you've done most of what is in the PA1A. This is very similar to PA1A if you've taken a look at that homework. It'll sort of recognize this sort of a very similar thing. PA1A, you read in 3 values, but this one you read in 2, do a quick calculation, print it out. That's essentially what PA1A also is. So I'm going to do the breakout rooms, and I'll throw see if I can get 3 to 4 per room. Dan will probably get shoved into one, and then I'll sort of jump around, and we'll just take a few minutes. It doesn't have to be too long, maybe 5-ish minutes, and then we'll do the wrap up. I'll let you know what's coming up next time, and then that will be it. So I will see most folks here in just a moment. Feel free to sort of talk about what's going on, share your screen. I'll make sure to sort of implement that so so one of you can share your screen. You can sort of talk about it. You can work it out. I know that if you're sort of already sort of good with programming, this will be relatively easy, but it's definitely worth going over, especially sort of following some of these rules, because the homework will be very strict on some of that stuff. Okay, so I'm going to create the rooms right now, and we can do this.
Your mic's off.
Yeah, okay. So the breakout rooms give just about a minute or so before they all close out. So wait for folks to jump back in, and then we will finish out for today. All right, so I think we got everyone back out. So exercise-wise, this wasn't a complicated one. As we go through the semester, of course, I'll put the more complicated ones typically at the end of the session. We haven't done a whole lot of complicated stuff today, but this is the foundation for most of what your homeworks are going to be. Read in some values, do a calculation, print something out. The calculation part is going to be the sort of complicated part where we start using more complicated features of Java. So for this one, again, relatively straightforward. Just read in a couple values. You could have these read values that are read in. You can have them be ints. That's perfectly fine as well. Make sure that when you're whatever you've sort of typed your values as, so a double or an int or something, make sure you use the appropriate scanner function to do that. So next int or next double, depending on what you want to use. The math library was very important here, math.pow for doing the power, and then of course printing it out in some useful way. The way that I printed out here was more sort of equation formatted. So it's going to put the number with 2 decimal places, caret the number with 2 decimal places, equals the result with 2 decimal places. So a little bit more complicated, got a few variables printed out rather than just sort of printing out the result is and then a number. But again, for the homeworks, there'll be some predetermined format that I will want you to use. And so you'll have to make sure to follow that. All right, so wrap up wise, you use those conversion characters and potentially use those flags as well to modify the look of your output, especially when you're displaying numbers. Generally, you'll want to use printf to sort of do this sort of more sort of complicated formatting, unless you're doing something simple, and then using something like print or println are just fine as well. The math library, super powerful, help you do calculations that you may not know how to program. Absolute values, easy. Square root, not so much to program yourself. So definitely take a look at some of those that are available. And in the homework documentation, I'll probably say something about it as well. I'll be like, oh, if you haven't used the sign function in the math library, this is how you use it. So I'll also do stuff like that in the directions for the assignment as well. Okay, so next time we start on control flow. For lab tomorrow, we are going to talk about PA1, which is available right now. Most likely, you will have to select your username again in the actual GitHub Classroom stuff. That's because I moved organizations, so you'll likely have to do that, but you shouldn't have to do it in the future. We will work our way through PA1A, so we're basically going to do that one together. I'll talk you through it. I'll show you the commenting style that I'm expecting for a regular PA part. And then for PA1B, you can stick around in the lab, work that one out, potentially get it done, or you'll be able to take off after we work through PA1A. PA1 itself is due next Thursday, end of day. Whenever I say end of day, that basically means as long as it's still Thursday, it's still fine to complete it. There is no place where you're going to submit it. Just make sure that you do the commit and push before the end of the day. And then there's just a little hint. We'll talk more about it in the lab tomorrow, but if you want to work on it today, that's perfectly fine. You're going to want to use probably integer division and modulus to complete PA1B. So 1A is the sort of easier one. 1B is a little bit more complicated. Uses a little bit different math to get done. So that's what's coming up. So I will see you folks in lab tomorrow. Have a good rest of your day.
Have a good one, Professor.
Thank you, Professor.
Thank you.
Yeah.
Professor,
Yep.
can I talk to you for a bit, like right now?
Sure. Yeah.
So, can you add me to the Blackboard class, because apparently the tutors have to ask the professor to be able to join the class.
Okay. Yeah, I can see what I can do for that. I don't remember. I did it before the last couple semesters as well. I forget who I have to email to get that to happen, but I'll make sure to look it up. It has to be it has to be through someone else who deals with all the Blackboard stuff. I think it's LIT, but I don't remember for sure. So yeah, I'll see if I can get you added in. That way you'll also get the emails too.
Yeah, and then for next Tuesday, I won't be able to attend because I have an in-person doctor's appointment.
Okay. Yep. Sounds good.
And so have a nice day, Professor.
Yep. So,
I actually had a question. Well, not question, but like, so I got PA1 like working. Like I got like the repository for that created, but like PA0 I like still can't, and I never got an email.
Okay. Yeah. Let me check. Let me check right now. Potentially. So I'll go back to the.
Thank you, Professor.
Yep. So,
I had a question.
Yes. Give me just a second.
Sorry.
So I created the repo. So let me go grab that. And let me check on it here. So it's going to be called, let me show you, let me share my screen here. So it's going to be called this. It's going to be this PA0. And I just used your WIT username for this. So check the settings here. So basically I sort of manually created it, and then I added you to it. So there should be, so it's got pending invite. Let me try that. This is your, is this your normal GitHub name? Okay.
Yeah.
So let me try it again. This, so it is, I missed one. Let's see. That was it. Okay, there we go. Okay, so this should, because I had you read as right, so you should be able to send stuff to it. So as long as that's it, whatever email you use to create this is where it should go. It might end up in a spam thing, maybe.
Yeah, I'll check it.
Otherwise.
All right, now I got the email.
Good. So yeah, so you should be able to go directly to this one. It most likely won't pop up under your own repositories. So here, if I click on my repositories, even though technically that was one that I created for you, it doesn't show up here. Typically, you do have to go over to see those specific ones, particularly the GitHub Classroom ones. You do have to go over to the little icon over here in the upper left. You click on it, and it should show up in the list that's over here.
Okay.
Yep. And you can do all the normal stuff afterwards. You can clone it and do all that.
All right. Thank you.
Yep.
Have a good day.
Yep. Yeah. All right, Matt, what's up?
Oh, yes. So I get the repository for PA1, but when to put it in, you like left click, go to team, and then apply patch, right?
We want to do. Let's see. You want to do so you have it on GitHub, but you don't have it anywhere on Eclipse, right?
Yeah.
So you want to do file, import, and then you do get projects from Git. And you can say clone URI, and that's where you put in the URL that you get from GitHub. So here,
okay.
So I'll go to GitHub Classroom. There we go. So in here, let's see, aim for right here. So I can actually go to your repo, and then for the code for that link, that HTTPS one, copy that, and that's what you'll put in to the URI here.
Okay.
and then it'll bring it in, and then you can do your whatever coding you need to do on it. And then when you're ready to send it back up, that's when you right click on the project, go down to team, and then commit.
Oh, I got an error.
Yeah. Did you want to share your screen? I can take a look.
Yeah, sure. Okay. So I copy and paste this. Oh,